Hi everybody, today I want to talk a little bit about constructions. And so students often ask me, why do we use constructions and in geometry? The reason for that is you have to put yourself into the setting where you don't have the modern technology, you don't have computers or measurements even, you don't have a ruler. You only have two instruments and you need to prove all your theorems and do all your measurements with only these two objects. And the two objects were a straight edge and a compass. And keep in mind that that straight edge do not have measurements on it. So that's the whole idea behind constructions. So you want to put yourself into that setting. Imagine that you do not have a ruler, you don't have technology. How will you prove these theorems if you are only equipped with a straight edge and a ruler? So I think most of you are familiar with how to bisect an angle, but let me go ahead and just very quickly review how one would do that, and then I will do a formal construction with GeoGebra and actually prove that the two, once you bisect the angle, that they are actually that the measurement of the two angles then will be equivalent. So I have an angle here, it's the angle ABC, and how you would do it, I'm just going to very quickly go over how you would do that. You would draw a circle, first of all, through both line segments, and you can see here that if you have that circle, then the length of this line segment would be the same than the length of that line segment, because those are both radii of the circle. And then from there, you will take your compass and you would draw a line, you take the compass, put the one point of the compass over here, and then you would make a little mark there. You would keep the compass open at the same length, and you would put the one end of the compass over here, and then you would draw another line there. And where those two values intersect, that's going to be where the angle bisector would go through. And it's easy to see why this works, because you had the same length here, you had the same length there, and then this length here would be equidistant to this length here. Okay, so that's the idea behind the construction of an angle bisector. And you can see that we didn't use any measurements. We didn't, use anything else than just the fact that radii are congruent in a circle. So, and so you had this circle, that radius, the length of that radius would be the same as the length of that radius, and then you constructed this circle over here, and you constructed the length of that radius over here would be the same than the length of the radius over there. And you can do that with a compass. So you can see how actually how powerful only a compass and a straight edge is. Okay, but enough of that. Let's go ahead and do this on GeoGebra. That was just a quick review of how to construct an angle bisector. But let's go ahead and do it formally with GeoGebra. So I'm creating my angle over here. And now what I want to do is I want to create a circle that goes through both of those line segments. So I'm going to go to my circle with the center through a point. My center will be right here at the vertex. And that will be my circle right there. So now I know that this line segment, the measure of this line segment will be the same than the measure of this line segment. And let me just put a point over there where the circle and the line segment intersect. Okay, very good. So now I have, because this is the radius, these are the two radii of the same circle. So these two measurements will be the same. And now what I need to do is I need to create another circle over here and use that same radius to find where those two will overlap. So the easiest way to do it, I think, would be to just go ahead and create a line segment. Let's call it FG or H. And then use my compass tool. So you can use the compass tool over here, and you need to select a segment or 2 points for the radius. So let's select these 2 points for my radius. So that will be my radius. And now don't click on it again, just move this. And I'm going to use this now as my center. And I'm going to do the exact same thing. I'm going to select another circle with that radius, move it over here, and my E now, this point here, will be my circle. Okay, very good. And I can see where these two overlap. Let me go ahead and put a point down there. It overlaps right there. And I'm going to get rid of all these extra circles. You can just go here to your algebra view and just click on it, and it will actually not show it. Okay, very good. So now let's go ahead and create that line segment from B to H. There we go. And what I claim now is that this actually bisected the angle. But let's see if that's true. Let's go to my angle. Let's measure that angle there. That has measured 25.06. And this angle, CBH, has measured 25.06 up to the second decimal equivalent. Okay, so that's very good, but this is how you would do it in the traditional method if you wanted to construct an angle bisector. But in GeoGebra, you actually have this feature built in. So let's go ahead and create just another angle. I'm just going to create this angle over here. And then if you go, where is that? Angle bisector. If you click over here, and let's just select the 3 points that we want to bisect the angle of, and you can see that it will create that angle bisector. So it did exactly what I did here, created those 3 circles there, and then it connected the 2 points. And we can, just to be sure, let's measure the, let me go back and create that point over here. Just going to put a point over there. And let's go ahead and measure that angle. So we have this. And that has angle measure 19.73. Let's do the same with KJL. 19.73. Very good. Okay, thank you.